Okay, recording started. So a few more students are yet to join, but we will start the session. Okay. So as we said in the training curriculum in our alumni group, so this is the plan for the OpenShift training. So mostly, I am interested more in concentrating on the AI like use cases. So increasingly many private clouds are training and deploying the AI models in their private lab environment. So that is the reason Red Hat has brought up with like 1 second. Some people are saying they are not haven't got the invite yet. 1 second. Oh, okay. I missed out few people. 1 second. Okay, let's continue. So basically, we like as I was mentioning in our group, like I want to focus more on the OpenShift AI use case, but at the same time, there are some students who are new to OpenShift, so we need to, consider the basic like introduction of OpenShift and the deployment options. So there are various deployment options are there, right? The like most common is CRC for developers and a single node deployment and multi-node deployments with one master and three master. So those we will see, and also DevOps use cases with respect to setting up the pipelines, using the Argo CD, GitOps, and the Tecton pipelines. Those aspects also we will look into. And we will also touch upon the virtualization, OpenShift virtualization. Then this is where I'm going to dive deeper. So here I have like given it in just 5 lines, but it will be expanded, and we'll be covering OpenShift AI, basically Open Data Hub in depth. Okay, so like this, we will cover as much as possible. The OpenShift regular part, like deployment and DevOps, we will complete faster. But this part, we will extend and we will dive deepest extent possible. So this is where the value is now with respect to the skills. So I wanted to focus more on this in this program. Okay. So this program should be called as OpenShift AI training rather than OpenShift training. So how many are new to OpenShift here? I know Satyendra has already been working with OpenShift. Okay, Faisal, Vivek, and so okay, fine. So two are new. Fine. Okay, good.
Hello, sir. Just can you just tell me the brief? In 1 minute. I mean, I just missed this, so I joined late. I didn't get the invite. So we are being. So you'll teach. Can I see the
Okay.
contents?
So
Okay.
basically, like whatever is there in the training curriculum, that is what we are going to cover. Like, the introduction of OpenShift, comparison with Kubernetes, those basic overview. And we will look into the deployment methods, starting with the CRC and single node deployment, multi-node deployments, one master and multi-master. And also DevOps use cases also we will like cover. And after, so these are all standard OpenShift use cases. Okay. So like all those we will actually cover, and we will touch upon OpenShift virtualization. Okay, so this is something that has like our students has been requesting for a long time. So we will just briefly touch upon that. But the like main focus of this program will be this, OpenShift AI. Okay, so basically it focuses on the like like MLOps infrastructure management, like how to manage the GPUs and how to do model training, how to have the Jupyter Notebook, TensorFlow, PyTorch kind, and the related tools deployed on OpenShift using OpenShift AI operator, and how to do the model training, how to serve the like model training. Okay, so those aspects is where we'll be spending most of our time going, like once the standard use cases are completed. So there are, say for example, for OpenShift model serving, so there is a Sheldon and there is KF serving kind of aspects or that we'll be touching upon. And when it comes to performance of the training workloads, how to manage the GPU and CPU resource management for the AI workloads during training times and as well as during the serving times, and how we are going to take care of the like edge computing aspect with respect to the AI integration, how we are going to run AI models at the edge with OpenShift. So those kind of aspects. So more like AI related use cases from, and actually but from the OpenShift point of view we'll be touching upon. So only this, okay, so this deployment part, so for the bare metal, practice, we can do it on nested virtualization. Okay, so that we will do. But most, like once we enter into these aspects, then we will be using a commercial OpenShift cloud. Maybe we can take it from Google Cloud or from IBM Cloud. We can create one, OpenShift infrastructure with the GPUs. Maybe if it is Google Cloud, we can also get TPUs and all, and then we can try to do the like AI like use cases. So that way, we will see in case of the nested virtualization aspects, we won't be having much of GPU resources. But when we go into the production setup, so then it is easier to get the GPUs and the TPUs from Google Cloud, and we can attach it to the worker nodes, and we can start doing the model serving and the AI workload management. So, like, so whenever we are going with the DevOps, even from DevOps also we can actually do it. DevOps and virtualization and AI. So wherever possible, we will try to use the commercial version of OpenShift. Okay, so that is the plan. Now, so like let me just briefly, like cover upon the overview of the OpenShift and how it is different from the Kubernetes. And after that, we will start doing like couple of deployments. So like one deployment so we will do two deployments parallelly. One, we will do it with CRC, the one of the easiest deployment, and the other one we will do it like one master, one worker node, and one bootstrap node kind of setup we will do. Like these days there are good Ansible scripts are available which takes care of setting up the KVM environment for DHCP and TFTP and DNS, everything. So they have very nice scripts that work seamlessly. So we will like use that, and we will do the deployment. Most of the times the issue will come like during the end of the installation. Some operators will start and some operators will not start. That is where the troubleshooting starts. So here they have something called as cluster operators. I will actually talk about it once we enter into the deployment aspect. So the cluster aspects, sometimes it works properly, sometimes it actually creates some problem. It might be because of networking or resource or some, like something or the other, especially if it is a multi-master node gone case. The load is too much, but it is a nested virtualization environment, so it can only handle so much of load. So it becomes very, very, very slow. So let's see how we can handle those aspects. Okay. So first, let's go with OpenShift. So basically, like when we talk about OpenShift, before that we should talk about Kubernetes, right? So, like anyone here who is not aware of Docker and Kubernetes? Everyone are aware, right? Okay, great, fine. Um, So anyway, this like Kubernetes being the open source platform developed by the Google, it automates the deployment, scaling, and management of the container applications. And so it just followed a Docker Swarm, and it became famous in 2015. And then it has been going well for a long time. The like only problem with the Kubernetes, especially the open source Kubernetes, is like it is not well suited for DevOps environment. Okay, actually we need to do a lot of like additional third party application deployment, like installation and management and everything, to make it enterprise ready. Okay, so that is one small issue with Kubernetes. It is a very nice software, open source, but like is it ready, is it readily available to be used on a production and like enterprise setup? No, so we need to add extra tools and we need to manage it. So that is where this like OpenShift comes into picture. So this OpenShift is basically a Red Hat solution. So basically it is a platform as a service solution that is built on top of like Kubernetes, and it comes with additional tools and services that helps the enterprises to have the development and the operational environment ready, without much effort. And like one like beautiful aspects of this OpenShift is it uses the Kubernetes operators a lot. So whether it is so it manages the entire cluster using these operators. So basically, it is used to automate the regular like maintenance of the OpenShift cluster. So most of the like services it will try to recover on its own, but when it is not able to, then we need to step in, debug, and we need to fix. So that is with respect to the like OpenShift. So this like OpenShift, like it has the integrated CI/CD, like pipeline and the role-based management systems, and the source to image tool, So so like like that, there are many like nice tools or that is very helpful for the developers and as well as the deployment professionals. They are like operators to like manage a Kubernetes environment. Okay, and it also has a support for SDN. So it like since it is actually coming from Red Hat, who promotes SDN like anything, so like this OpenShift has the support for SDN, so which is also widely used in the like enterprise environment. So it has an like native support for it. When it comes to the user interface, this Kubernetes provides a bare minimum, like functionalities. Okay, so but when it comes to OpenShift, they have a full-fledged enterprise grade, like user interface. So like where the multiple user, like actually users can log in, and depending upon their roles, they'll be allowed to do, whatever activities that is possible for them on the platform. Okay. So this is the overall difference between the OpenShift and the Kubernetes. So this, okay, there are some nice internal services that comes as part of OpenShift. So one is the container registry. So in case of Kubernetes natively doesn't come with a container registry. So we used to set up the container, like registry from scratch after deploying the like Kubernetes. But here the container registry comes as part of the OpenShift. So generally the container registry means we use a Docker Hub, right? But here this container registry is a private registry, so where we'll be able to store and manage our container images. So that is one nice thing. And second, so as we are talking with the images, so it has support for something called as image streams. So this is actually OpenShift feature. We won't see it in Kubernetes. So this feature basically helps in application deployment and management by allowing us to, track the image versions and it also has something called as templates that so basically they are reusable templates that helps us to deploy complex applications. So we will see them some examples we will see once we have the OpenShift up and running. And another nice feature is source to image. So this is basically, build technology that has been introduced by the OpenShift product. So when you provide the source code, it will do the build and it will create the image and it will help us to deploy it on the OpenShift platform. So basically, it is called a source to image. Okay? This is another like unique feature. And since this OpenShift is using these operators heavily, so this OpenShift has an embedded operator hub. Okay? And then like we can also access the like this like Kubernetes like operator library, the hub from the outside, and then we can deploy and manage complex applications using the operators. Okay, so these are some of the unique features of the OpenShift. So as usual, so just like the Kubernetes environment, here too we have master nodes and like worker nodes. So as we go ahead and then deploy the like cluster, so like mainly there will be two kinds of nodes. One is master nodes and another one is worker nodes. So worker nodes are the places where we actually deploy our applications, and like this like master nodes are basically controllers, which will manage the entire cluster. So there are main like components are there as part of the master node. One is the API server, just like the Kubernetes API server, like almost the same, but here we have two API servers. One is for Kubernetes and another one is for OpenShift. So when we do the, this layer, okay, when we list the cluster operators, we'll be able to see them. There are two kinds of API servers. One is OpenShift and another one is Kubernetes. And the second one, like as in the Kubernetes here too, we have the controller manager. So the like main job of the controller manager is to ensure that whatever is the desired state, that we have defined, whether it is the application workloads or whether it is the cluster, everything is managed by this controller manager. Okay, so it can be node operations or it can be application replication or it can be endpoints. It can be anything. Everything is managed by the controller manager. Okay, so that is one nice thing. And of course this is something, it is not new, it is part of the Kubernetes. Then we have the scheduler, and another well-known component of Kubernetes. So this takes care of scheduling the pods to appropriate worker nodes based on the resources that we have defined for the pods. Okay, so like if the resources are available in the worker nodes, then those worker nodes will be selected. Sometimes, of course, the selection will also be based on taints and tolerations, right? So that is also taken care by the scheduler. And when it comes to the worker nodes, the main component here is the kubelet, which talks with the container engine. So the container engine that has been used by the Kubernetes recently is CRIO, right? So this is the Kubernetes native container runtime implementation. So this integrates, well with the like OS, and it like works. Like efficiently. So before we used to use Docker, but now it is the CRIO that we generally use with Kubernetes, and the same is used here, even here in OpenShift. And when it comes to networking, of course, the SDN is supported, so it takes care of pod-to-pod communication within the cluster. Right, and all the common, like this, like Kubernetes related, like resources are all supported here. So basically, when we talk about the Kubernetes, we talk about pods, and we talk about services, ingress. Okay, so along with ingress, so here we have something called as routes, right? So like this, like all, and then like deployment and replication set and everything is supported. And on top of it, of course, there are some extra, like entities like this image streams and everything are also supported. Okay, so once we start working with this, you will be, easily getting used to. So the deployment, so there are two kinds of deployments that we can go with OpenShift. So one is on-prem, like which generally happens on bare metal servers in the data centers of the respective companies. And the second one is the public cloud part. So basically AWS and Azure, GCP, and IBM, of course, who owns OpenShift Enterprise Edition. So, like these are all the most commonly used public clouds where we can deploy the OpenShift and scale it effortlessly. And on-prem is also, important. So here the on-prem will be trying with CRC, and we will not be using any like in a bare metal cluster. We don't have bare metal cluster. So instead we'll be using KVM to create VMs that is going to represent the bare metal machines. Okay, so for that there is one nice like GitHub project is there, so that we will use, and we will, and it is written in Ansible, so it takes care of setting up the entire environment within an hour. So before we used to take at least 3 hours to set up such kind of an environment, because we need to install OS, we need to install DNS and everything. And Satyendra knows, sometimes we face a problem with the DNS, and it becomes a big problem with OpenShift installation. But now that Ansible script has really made our job easier. Okay, so that we will show it to you how it can be done. And of course, the OpenShift, just like OpenStack, also supports multi-cloud and hybrid cloud, like environments too. It actually supports. Uh, so first, let me go ahead and then start with the multi-node deployment, because CRC is pretty easy. Okay, so maybe we can do it both, but first I will start with the multi-node because it is a little bit more involved and very very nice to see. That the like, CRC is very very easy. Okay, so nothing exciting, to explore, but it is the like quickest way to like bring up an OpenShift cluster and play around. So CRC is like nice from that point of view. But like we need a proper environment, right? So first I will do the full-fledged OpenShift deployment. I will show you that GitHub site and everything. Okay, we will initiate that, and parallelly we will also do the OpenShift installation using the CRC. Okay, both we will do parallelly. Fine. So for this, as usual, we'll be using our Google Cloud, and we'll be using our Google Cloud environment. Um, and of course, Google Cloud environment supports like nested virtualization. So that is what we are going to do. So as I'm going to do the deployment, as usual, I'm going to record all the steps, and I will upload the PDF document to our LMS. So let me create a new Word document. OpenShift deployment.
So hi Rajan. So we'll use open source OpenShift or Red Hat?
We will use both. The only problem with Red Hat is it requires license. So there is a 60-day license, but I have already used it. So I need to create a new account and I need to try to use it. Anyway, the steps are the same. So whether it is going to be Red Hat or whether it is going to be OKD, the steps are the same.
Okay. Because there are modes, right? UPI mode, IPI mode, user
Yeah,
provision.
so yes, so actually here we will be going with the user provisioned first, and IPA
Okay.
we will do it on Google Cloud. So the Google Cloud and Red Hat, they have the IPA set up together. So the advantage that so there our work is much easier, because the infrastructure takes care of the entire provisioning, and I love to work on that environment, and that is what we are actually going to use in most of our training sessions. I hate UPA because too much of work. But yeah, but we will start with the UPI. But I prefer to work
Mhm.
with IPA. Once this AI came into picture, I'm not even having interest in working in cloud. Everything is automated by AI. So our
Yeah.
okay, so let's start. Okay, so the first thing is we need to set up a hypervisor. So this one, I will call it as multi-node OpenShift deployment, multi-node with one master, one worker node, and of course with the bootstrap. Okay, so
But you need
so
three master node, right? Or one is enough?
that is for HA. So here I'm trying with non-HA deployment. HA requires more resources. We will do HA in IPA method.
Okay.
But I will show you the steps, like the only thing is then like number of master node instead of one, we should change it to three. So and then, so here we will be deploying three, we'll be setting up the scripts for three master nodes and three worker nodes. We will try to run it, but it always takes a lot of time to come up. But I will show you both, no problem. The steps are same, whether it is HA or non-HA. Like only, like the machines has to be ready with respect to DHCP and DNS and all those configurations. And the second is we need to change the ignition file. There is a like configuration file where you need to specify the number of master nodes. There instead of one, I need to say three. That's all. So rest the OpenShift takes care of. So let's do the deployment. So the first aspect is we need to set up the hypervisor. So set up hypervisor. So for setting up, hypervisor, like in fact, I have one image, so that I saved yesterday to bring, to quickly bring up the hypervisor, but I don't want to use it. I will, try to create the hypervisor from scratch because these days I stopped managing the images in Google Cloud. Okay, so because I'm not taking the cloud training programs much these days, so I don't want to manage them. So instead, I will show you, how to have the like environment ready in few minutes. So whenever you want to set up the environment, you can just quickly create it. Okay, so here, let me bring this notepad, and I will also bring the command. I have it ready. I will first explain the command here. Okay, let me increase the. Okay, good. So this is the command, so this is basically a gcloud command. Okay, this is a CLI that we'll be executing on the like Google Cloud CLI interface. So here we are creating a gcloud compute instance, basically a VM. I have named this VM as OpenShift. Okay, you can give any name for this. And this is the project. So the like actually my project is RTC in OpenShift. Just ensure that you are replacing it with your project ID. So this project ID, in case if you're new to Google Cloud, you can just get it from here. Just go at the top, you'll be able to see your current project, and the ID. So here you can see the ID in my case is RTC OpenShift. So just use this. And the second zone, I have selected Mumbai. And then the mission type. So here I have selected the mission type as N2 standard 8. This comes with 32 GB, RAM and 8 vCPUs. But if you are going with um, this one, three master nodes, better you go with 16 CPUs and 64 GB RAM. Okay, so maybe like the 8 CPU, most of the free tier account allows, no problem. But when you go to 16, they will not allow. Then you need a paid, account, and then you should also request for the quota, because by default they allow only 8 CPUs on Mumbai region, but you can request them to allocate more, this CPU quota, okay, so that you can deploy the OpenShift. So, I will just try. So this is a new uh, project, and I was not having the quota. I just requested, and within a day they gave me the quota. So it's not a big deal. So in case if we are going to use that, we need to update this to 16. Okay, that's all. N2 standard 16. So next, the network interface part. Okay, this and all you can just blindly copy and paste on failure restart and maintain. So here I'm using spot instance, because the spot instance, the advantage is the cost is very less, but at the same time, the VM might be stopped anytime. So whenever they need the resource, they might stop the VM. So okay, just ensure you mention Let's stop. Okay, otherwise they will delete the VM. Okay, so it is better to have like explicitly stating to stop the VM. We don't want the VM to be deleted. And these are all the default service account details. So generally, how I got this like command is I just went here and clicked on compute engine, create instance, and give you a name. I gave the name as OpenShift, or I will call it as my lab. And here, go to Asia, South 1, Mumbai, zone any. Here you select N2, okay, N2, and standard 16 or 18, whatever it is. So we can see the pricing here, how much it is and all. So here you can see pricing per hour, $75. Sorry, 75 cents. That's it. This is all done. Now let's go to OS and storage. So this is like OS default is Debian. So it is perfectly okay with stick with Debian. So here you can see Debian 12 is the latest one. The size of the disk, it is better to change it. Okay, so this 10 GB is not enough. So go with the 200 GB. And if you're like aiming for HA, even 300 is also perfectly okay. Okay, so select this. And the advanced here, I need to specify the provisioning model, go with Spot. Okay, so Spot is the provisioning model, and here you can see by default the the VM termination aspect for Spot is stop, so that it can be restarted and we will not be losing the data. In other clouds like AWS, if you are using Spot, and if they need the resource, they will kill the VM. They don't care about your data. But here, at least the default is Spot, but we don't know when they will change the default from stop to delete. So better to explicitly specify it. So that's why in CLI we have explicitly specified it. And that's it. Now if you just click on the equivalent code, you will get the this like command line code here. So you can see compute engine, my lab, and project zone, mission type, and everything is there. Okay, so you can just copy it, modify it, and then you can use it. Okay, so let me close this. I don't need it. And I will also click on cancel here. Let me go to the Cloud Shell where I can run this command. Okay, and one more thing is, since we are going with the KVM setup here, we need nested virtualization. So remember to have this enable nested virtualization. So only then we will get the KVM flags, basically VMX. So the VMX flags enabled. So otherwise we will not be able to have the VMs up and running. So just ensure that you have this setup. So just copy this already, paste it. Simple. So create a VM in GCP, nested virtualization enabled. So this will immediately bring up the VM. Yes, Ajay?
What will be the ways of running system in this VM?
Ajay, your voice is not clear.
Is the operating system on this VM?
Operating system, the default Debian Linux. It doesn't matter. Okay, we can use Debian, Ubuntu, RHEL, Rocky. We can use anything. It is just a hypervisor. We will not be doing much on this other than managing the VMs. And the VM management, it's all using VARSH, right? So there is no big difference. Okay, so just create this and let's log in. Okay, I will delete this. So here, go to session, SSH, and we need to give the IP address of our VM. Let me get the external IP. This external IP will change every time. I'm not using static because these days statics like IPs they charge. So I don't need a static IP. So I will go with the ephemeral IP and click OK. So
Okay.
here in this environment, I have already configured the SSH keys and all. So I'm not specifying the SSH keys. But in case if you want to manage the SSH keys, just go to settings and here you can say SSH and here you can enable the SSH agent and add all your private keys. So that way you don't have to give it every time. And the second, remember to configure your public key here in metadata. Just come here, compute engine metadata, here metadata. There you will see the SSH keys. So click on edit and add your public key. At the end, you will see Rajan. This is going to be my username. Okay. So most of you know about this. In case if you have not worked on it, okay, just I wanted to show it to you. And also enable the serial port. Okay, so the SSH key is here in SSH key section. Metadata, we need to enable the serial port. So in case if our hypervisor misbehaves, at least we should be able to get the console because SSH will stop working in case of any problems. So we need to log into the VM, maybe using a serial port, and we can try to enter into emergency mode and we can try to recover it. So for that purpose, always better to enable it in your project. So that's it. So here we have our VM up and running. Let's go and connect. Okay, here I am. I've just connected to our VM. Okay, fine. So once we have connected to our VM, so we will also see the before in my old OpenShift and all, I used to install X Windows and we used to get remote desktop and all, right? So, but now we have Cockpit. That like makes our job much easier. But we need to open port number 9090 in our network. So that also I will do. We will open port number 9090 for the Cockpit console. So let me do that. That also I can do it in the gcloud command, gcloud CLI. Come here. Where is the CLI? Oh, it's at the bottom. Okay. So this is the command gcloud compute. Give the project name, firewall rules, create OpenShift. OpenShift is the name of the firewall rules. It will allow ingress port 9090 from anywhere in the web. Okay. As of now, I'm just allowing it to for everyone to access. Oh, it's already there because I've already pre-created this. Okay, in case if it is not there, it will go through. Okay, so this is so in case if it is not there, it will be creating it like this, and it'll say it has been allowed and all. Okay. Now, uh, so we can quickly check the RAM and the CPU details. So let's check the RAM. So here you can see it has 64 GB RAM, and let's also check the disk here. See, it has 200G disk. And you can also do LSCPU to ensure we have the VTX KVM enabled, and here you must be able to see VMX also enabled. Okay, so everything is taken care of. And we can also do egrep -C, VMX, proc, CPU info. There you can see there are 32 threads. Basically, there are 16 CPUs and hyperthreading is enabled. So we have 32 threads with VMX support. Okay, so this is to verify the environment, verify the resources. Now we can go ahead and then start the deployment. We are going to create one VM. Okay, that is going to be our Bastion host, where we are going to do all the tools deployment, whether it is DHCP, DNS, TFTP, and like OpenShift installer, everything we will run it in that VM. Okay. So here, this is the important flag, VMX. And here you can see the visualization features. So just ensure, so I'm just putting it here so that you should be able to ensure that in your environment you're able to see all these numbers before you proceed with the deployment. Okay, that's it. Okay. So now we will first deploy the KVM, right? Um, so here we have the VM ready. Let's deploy the KVM.
So this will be IPMI, right? IPI.
Mm, which one? This one is UPI,
UPI. Okay.
user provision, because we are going to provision all the machines, not the infrastructure.
Okay.
If you're using OpenStack or Google Cloud or Azure, then we can use IPA. That we will do it in the next sessions. Okay, so first let's do the deployment. I will first update the repository.
So this is exactly if I want to do Red Hat OpenShift.
Yes, same steps, not no difference.
Okay.
Great. See, in case of Red Hat OpenShift, we need to provide the pull secret and all, so that it can get the images from Red Hat. Yeah, and in case if you are using OKD, you don't have to provide the pull secret. So here I'm just updating the existing packages. Next, I will install the KVM packages. Okay, all done. So let's install the KVM packages now. And let me also install Work Manager, QMO system, and those things. Maybe I can just do it in the next step. So here I'm installing QMO KVM, which is the main process that manages the VMs, and libvirt daemon. This is the service that manages and creates the VMs. And the bridge for brctl command, virt install command, and so these are all sub packages. So there are some group of packages that we need to install for the KVM to be up and running. So we will install all these things. There is also one more, that is Work Manager QMO system, that also will install now. And we need to install whether the vhost kernel driver is loaded. Okay. So here you can see the like vhost virtual host networking is not enabled by default. So just to ensure that you load this kernel driver vhost network. So this takes care of the virtual networking aspects. So just load them. So once it is done, just ensure that it is also put into the etc modules file so that every time we reboot the system, it is automatically loaded. Okay, so I've just added it. Now we can also go ahead and then install the rest of the other packages. So install KVM packages. Load vhost kernel driver. And also install Word Manager and other tools. Once done, we should be able to see the libvirt up and running. Okay, play the screen. There you go. Oh, what? Okay, it's still preset enabled, but it hasn't started. Okay, let's start this. What is? Okay, it's up and running. Okay. And also ensure whether the virtual network is there. By default, the virtual network doesn't come up. That which BR0 doesn't come up. Anyway, we'll be creating our own virtual network. But just to for the completion sake, I will also start the default network bridge. It's not required. We will not be using it. In case if you want to use it, it is better to start it. So start libvirt default network bridge. So here you can see it is missing. We have only localhost and the network interface of Google Cloud. There is no where BR0. It is missing. So to bring it up, we need to start that network. So by default, the auto start is disabled. If you do VRS search net-list -all, there you can see auto start is by default disabled. That's why it doesn't come up automatically. So let's start it. So I have enabled auto start. I've also started the network. Now if you check the network, you should see auto start up and running. And if you do IPA, we should see the virtual bridge interface. You can also do brctl show and you should, oh, brctl command not working. We installed brctl command, strange. I will see that. Maybe it is not in the path. All good. See, let me see what happened. Sudo update db. We don't have update db. Okay. Sudo apt install mlocate -y. I will add this mlocate also into our list of packages. It's a very useful tool to have. Okay. It is in sbin. Maybe sbin is not there here. So sudo brctl show. There you go. It shows. So if I do sudo brctl show, it comes. Okay. No need to give the complete path. Just add sudo before it. Okay. Now let's set up the cockpit. So we need to just install the set of cockpit missions, the packages. So here you can see cockpit missions, and cockpit podman. These are all required for cockpit. Xauth is not for cockpit. It is for like this X11 forwarding, SSH forwarding, because to get the user interface, I'll be using the X11 forwarding. If you just see here by default, when you try to log into your VM, X11 forwarding is disabled. So we need to enable X11 forwarding. So that also I will do it in a single step. Otherwise, I can do it in a separate step. That's better, right? Okay, let me remove this. Okay, done. Now we can start the cockpit socket service. So just to do systemctl enable cockpit socket and start the cockpit socket. And then you should see that up and running. And the port that is used is 1990. That's why we enabled port 1990 in the firewall of Google Cloud. That's it. So now we can go ahead and then provide the external IP address of our VM. Yeah, just say http:// that external IP 9090. Just provide this. You should be able to access the cockpit user interface. Now go and provide the username and password.
So we're not in Bastion mode here, right? It's just building the hypervisor.
Yes, we are setting up the KVM now. The next step will be the Bastion host and initiating the deployment. Okay, so here we have, so like now to access this, we need the password for our username. Let me reset my password because by default, my user account will not have a password. So here I just gave the password. And then a password to use in cockpit web interface. Okay. So here I will provide that username, your like Linux username and password. Press enter. You should be able to log in. There you go. So we actually landed here. Let me take a snapshot of this. Okay. So after login, it'll be like this, and also turn on the administrative access. That's it. So we're able to access. So here you can manage the VMs, you can get into their console, and you can play with containers. It's a very nice user interface. Let me turn on the admin access. Okay, you are now admin. So here you can see you can access the VMs. So as of now, we don't have any VMs up and running, but once we have the VMs up and running, you should be able to see it here. Here you can see the virtual network. We have the default virtual network and its details. And we'll be creating a new virtual network for our like setup. Okay, so that also we will show you. And here you can see in case if you have created any containers using Podman, you can manage it here. And the networking interfaces, VRBR0 and the default networking, everything you can see it here. Basically, network manager aspects and Linux services, sockets, targets, basically systemctl. It is an interface to systemd, and you can also access the logs here. Okay. So fantastic, right? So if you have not worked on a cockpit, you can start doing it from now. So here you can see here, so, here we also get the terminal for quick access to the CLI. There you go.
So
That's it.
OpenShift virtualization uses same KVM in the OpenShift virtualization. Is
We
the
will actually
same
talk
KVM?
about that later. We will talk
Okay.
about that later. Let's just complete this, because maybe later I will give this video to someone who wants to learn OpenShift. So we will focus on this topic first. Okay, so here, okay, so the cockpit is ready. So next we can create a virtual network and start the installation of Bastion host. So create KVM virtual network for OpenShift. So we can use the default virtual network. I'm just creating my own virtual network. So one reason why I'm doing this is the script that I'm using, the one that I got from GitHub. It uses a specific IP. So I thought, okay, better to go create a new virtual network so that I can directly use that script. Because our main focus is OpenShift, not the environment setup. So I want to just complete this quickly and move on to OpenShift. So here I am defining one virtual network. So I'm just creating a virtual network with the name OpenShift 4, and this is going to be the IP range 192.168.100.x, and it is going to be /24 prefix and NAT. It will automatically take care of the network address translation. So this enables internet access, and those are the NAT ports. Okay. Now let's go and define the network and proceed with VM creation. So the VM creation too, we will use the existing templates. Let's not do the OS installation and all. Okay, just mark the network to auto start the network, then ensure it's all yes, yes. And if you do brctl show, you should see the second network up and running. Good, that's it. Now copy this, and then you can also do b open, okay, IPAS OpenShift 4. Oh, wait. What's the interface? Oh, spelling mistake. Okay. OpenShift 4. There you go. Its interface is also defined on the hypervisor. So this is going to be my last OpenShift batch. And we will make this OpenShift AI as part of our AI like a Saturday, Sunday batch going forward.
Which means this batch will be moved to Saturday, Sunday after this?
No. This
There,
batch will go on. We will complete this. There is no OpenShift batch again. This is my
uh-huh.
last OpenShift batch. And the content of this OpenShift batch, basically OpenShift AI, we will put it into the regular AI batch going forward.
Oh, okay.
And they will not be focusing so much on OpenShift. So I don't have to go in depth. I can just show them, okay, how to deploy OpenShift, maybe CRC, show them how to deploy the AI operator. That's it. We can directly go into other aspects. Okay, so here we have everything done. I think even these two, I can put it under KVM setup. Yeah, done. Okay, now let's set up the Bastion host. So the Bastion host is the place where we will be having all the utilities up and running. A very important um, VM. Okay, so let's go and create the Bastion host here. So for this, we will use OS templates. So there is something called as Word Builder that has OS templates, ready-made images. So we will use that and we will create this VM in few seconds. So check available OS templates. I will go with Fedora for this.
So Fedora and Red Hat same commands, right?
Yeah, same comments. That's why I'm going with Fedora for Bastion. So if you just do sudo word builder, it'll just check that it's a DB and it'll give the list of images that are there. So it has support for CentOS, Debian, Ubuntu, all versions of Fedora. I will give the output as it is. I'm not truncating. So the image that we will use is the latest one. Fedora 41 is latest. Let me go with 40. Okay. So that is the one that I'm going to choose. So let's go ahead and then do the deployment. So first for the VM, I need a QCode disk with the OS pre-installed. So let me create that. Create Fedora 40 QCode disk. So here basically what we're doing is we're using the word builder and we are specifying the template name, format QCode2, the size of the disk 20 GB, and we are providing the location where we want to store this disk file, the root password for the default root password for our VM. So it will have the OS pre-installed. So once it is done, so the disk will be ready. And next, we need to just attach it to a VM. So we'll create a new VM with the same disk, and in that VM we can specify how much RAM, how much CPU, and those details, and it will be up and running. That's it. So now it is downloading the image. Almost done. So it's created. 1 second. Okay, let's copy this. It has 18 GB free. I think this, okay, that should be enough for running the standard services. Just we need to note down the password. We will reset the password after we log in. So just ensure that the QCOW2 disk is there. So 21 GB. So next part, we need to create the VM. Create Bastion VM. So we already have the disk ready. We need to just attach the disk and create the VM. That's it. So I will create a VM with 8 GB RAM and 2 CPUs. See here, name, Bastion host, 8192 RAM, 2 CPUs, path to the QCOW2 file that we have created, and the bridge, I'm using OpenShift 4. Enter. Don't worry about the deprecated stuff. It doesn't matter. Now it's starting. Basically, we are getting, okay, we got access to the serial console. So these are all boot messages. Okay, there you go. Root, give the password, we log in. And first step, change the password. And change the password here. I have given the password as A. Okay, that's it. Here's the screen. So by default, the IP is not configured. Let's configure an IP address here. Configure IP address. So this is using network manager. So we need to use NMCLI. So here you can see, I will delete that wired connection and I will recreate it with our IP. That will be much easier. So here, if you see, I'm adding a new connection ENP1S0, just like this name. And auto connect, yes, manual configuration, IP address, gateway, DNS, all done. So now if you do IPA, we should be able to see the IP here, look into the routing table, all are fine. Now we should be able to ping 8.8.8.8. We should also try to ping Google. Okay, yeah, we are able to ping. All good. Now we can start doing all the services setup. So here I am explaining and documenting. So it has taken almost 1 hour. But if you just directly copy and paste the commands from the documentation, you should be able to do all the steps within 20 minutes max. So within that, you should have all the services up and running, and you should be able to initiate the OpenShift because you can see everything is pretty fast. So let's go ahead and install the necessary OS tools, update OS packages, and install basic tools. So now we are into Fedora. So start using DNF. So here we need to install git and wget, curl, and a tree command, tar command, all those tools. Those doesn't come as part of this package. So whatever is not there, we will install it. You can see the image is a little old, so almost 200 packages it is getting updated.
So hi Rajan, you'll upload the video today or tomorrow?
Today I will upload.
Okay.
Please remind me after the session, after 1 hour, I will upload.
Okay. No worries.
The PDF I will upload immediately. The video just, well, anyway, they will take 30 minutes for it to be available. I will also upload the transcript for this. Okay, it's ready. Let's install the tools. I will also change the name of this mission to Bastion. And let me power off it. Okay, so now I have powered it off. I will let me see whether I can take the snapshot from the here. So here we have the Bastion. It is in shut off state. All good. Okay, unfortunately, it doesn't have the snapshot mechanism. That's okay. So here, sudo var research list hyphen fn all sudo var research auto start. So that way we don't have to start it manually. It'll automatically start every time. I will enable auto start for all the VMs. That's it. Now let me also start it. Enable auto start for Bastion VM. So now either we can SSH or we can get the serial console. So to get the serial console, just to do VRSH console, and you should get the serial console. You can log in like this. This is one way, and I have just come out. You can come out by typing control square bracket. And we can also SSH into this. I prefer SSH whenever possible because we get better user interface in case of SSH. CL console, it restricts the screen size to off. I think it is using 80 lines or something like that. I don't know what it is doing. So generally I don't use it. I prefer, but you can just come out of this by using this key combination. So to SSH, you can say SSH root at the rate of 192.168.100 or 254. There you go. We are inside. Looks like I haven't enabled SSH. 1 second. Let me go to console. Maybe I need to enable permit root login. Yeah, that is the problem. So just set this to yes and restart the SSH service. Ensure it is up and running. That's it. Now I can come out and try to log in here. It should go through now. There you go. I'm able to log in perfectly well. So we have logged in. Now we can go ahead and then, like actually make use of that make use of the Git repository and install all those necessary packages. Okay, let me do that. So Bastion host is ready and let's install the services. Install Bastion VM services. So first we have to install Ansible because the entire repo is Ansible based. Just ensure we are in Bastion host SH session and run this. So along with the Bastion, I'm installing Git and all those. I think we have already installed these packages, but it's okay. It doesn't harm in installing it again. Yeah, mostly it is installing only Ansible. Other tools are already installed, so no problem. So this repo, I have a clone. I have forked the repo under like Rhythm Trainer's account, but you can see the original, the contributor here. So we should mention him. He has done a fantastic job in saving our time. So clone OCP4 Ansible Git repo. So wait for this to come up. Yeah, it's done. Let's do git clone, give that URL, enter. Okay, it's done. So the repo has a lot of nice packages, nice tasks. So let's go into OCP, do a tree. There you can see the necessary templates. So the templates for the zone file, reverse proxy. So in this reverse DB, zone file DB for the name daemon, for DHCP templates, HA proxy, DNS, PXE for Bootstrap worker and master nodes for the automatic, like the kickstart of installation. So all are here. One second. Okay, so I'm back. Good. Okay, so here, okay, if we have to do any modification, here you can see we have the Ansible configuration file. So the default is the inventory file. So since we are focusing on the local machine, the local host is configured and the connection is local, it is explicitly specified. Okay, so in case if you are not running this Ansible as a root, just ensure the privilege escalation, everything is properly configured, and just do a tree here. Okay, so here you can see the DNS configuration, DHCP configuration, load balancer configuration, and a TFTP PXE configuration. Everything is here as tasks. And templates are also there. And this is the main.yaml file, which initiates all those things in a single go. Okay. Sorry, this is the variable. Okay. So if you just look into the variable here. Oh, sorry. What did I do? Okay, there is a space. Fine. So here in the variable, you'll be able to see the disk where we are, installing the Red Hat Core OS on the master node and worker node. So the default is VDA. Okay. And here you can see the Bastion host and its IP, its network interface. So you need to check the network interface of the Bastion host, IPA. And here you can see this is not ENS, it is ENP1S0. So just ensure that you update it. So come here, update the network interface to ENP1S0. That is the only update. domain example.com cluster ID and DNS default ones. And this is the load balancer IP. The default value we'll use because that is the same mission. The bastion host will be acting as the load balancer in case if we are going to do a HA deployment. And this is the DHCP, the router IP, the IP address of the hypervisor, broadcast, and network mask, and the pool start and the pool end. So from 10 to 50, it will take the IP address for IP assignment during DHCP. And what is okay? NTP under configure. Next, we have the bootstrap. So here the MAC address and the IP address are all pre-configured. Okay, and same with the master one, master two, master three. So here, we have set up for master one, master two, master three, but you don't have to use it. Just one master is perfectly okay. Similarly, worker nodes also, 3 worker nodes are configured with their IP and MAC address. So this MAC address is required for IP assignment. Okay, so for other purposes, it's actually used. So nothing has to be done, or like everything we can use it as it is. Just the network interface alone, like remember to change it. That's all. Otherwise, this is perfectly fine configuration variable file. So configure Ansible variables, or I would say update network interface name in Ansible wars file. Other than that, we are not doing any change. That's it. Okay. Now we can install the DHCP server and DNS and Apache web server, HA proxy. That's it. 4 or 5 services. Quickly we will install and we will initiate the OpenShift. Okay, first install the DHCP. So here first we are installing the DHCP server. And next we'll ensure it is up and running. There is some error, it looks like. Let's see, maybe the configuration issue. We need to change the configuration. Let's see the default configuration. Okay, it's empty. It's empty. Okay. Anyway, let's take a backup of this. So in case if we want to refer to it later, we will create the DHCP configuration by calling the configure DHCP task. This will create the configuration file for us. Let me show you quickly what this task does. So it takes the template and does necessary modification. That's it. Let's go into this file. There you go. So what it does, it takes that variable file as the for the input data, and like it is importing tasks from main.yaml and this is the most important part. It is taking the DHCP template file and it is copying it to this location, and it is restarting the DHCP server, and that's it. So in case if it is not UEFI, then use this. If it is UEFI, use this configuration file. So depending upon the environment, it just uses the respective templates. That's it. So if you just, so the template that is defined here does the job. Just open that. So here you can see it has all the configuration. So basically what it does is it takes the data from the variables that we have defined and it puts it here. See the Ethernet MAC address and IP address to offer, the name of the machine, everything is put in. So it is just generating the data, that's it. So once it is done, if you try to cat that file, you will see nicely done configuration. So bootstrap machine, master 1, master 2, master 3, worker 1, worker 2, worker 3, all the entries are there. So based on the IP address, so when they send the DHCP client request, okay, they like MAC address, sorry, the MAC address will be matched and the IP address will be offered. That's it. And this is for this subnet. This is the OpenShift virtual network that we have created in KVM and the range from 10 to 50. Okay, and this is the interface. This is our interface. So this is the configuration file. Let's copy this. So, like in case if you're reusing this script for your office purposes, just ensure you do the necessary modifications here. And we can also check the status of the DHCP server now. Since we have the configuration file in place, it should be up and running. And Ansible restarts the the DHCP service. That's why it is up and running. After placing the configuration file, it actually does it. Okay, good. So DHCP is ready. Next, we will set up the DNS. So install DNS server. So we'll be installing the bind DNS here. So first install bind and bind utils. We need bind utils because we will be using the commands like dig to test the entries, DNS entries. So once it is installed, start the named, right? And we need to create the zone file and all, right? So for that, there is one script, a shell script. We will use that. So this will create everything that is required. So what we will do is, so it's like this script, we'll be using it while starting the DNS service. So let this be in user local bin. Now we will run the Ansible playbook for creating the bind DNS configuration data. We haven't executed the script yet. We're just executing the Ansible. Now, if you look into the var name daemon directory, you should see the zone file DB, and as well as reverse entries DB. Okay, both DB should be there, and name DB should be that, like name daemon should be up and running. There you go, it is up and running. So, and you can also try to like query this etc server. It should be able to provide, it should be able to point it to master 1, master 2, master 3. That's it. So if you look into the zone file here, you'll be able to see the entries. So if you want to modify the entries, just go and modify it. So here you can see the 3 master nodes, 3 worker nodes, and etcd machine IP addresses, and the OpenShift API apps. This is the wildcard for applications that we are going to deploy. Bastion host, all are there. Okay, let me also take a look at the other file, reverse DB. So here is the reverse entries. So if you say 11, it will map to the domain name. So let's put this into our documentation for easy reference. That's it. So let me put a small entry here. Forward DNS zone file. And this one is reverse DNS zone file. That's it. So everything is done. And yep, here we're just testing the entries. That's it. Okay. So let's also enable the firewall, and we'll also ensure the Bastion host uses our DNS instead of 808.808. Okay, so that also we need to modify, right? So modify local system DNS server. So we will do it using the nmcli command. So we have enp1s0, right? So there the DNS entry, we'll modify it to the local IP. We will reload and bring the interface up. That's it. Now we can try to test Let's try to provide the host name and we should get the IP address of it. We will also enable the services like DHCP, DNS, FTP, sorry, HTTP, HTTPS, everything in firewall and reload the firewall entries. Okay, all done. Now let's set up the TFTP service for PXE booting purposes. So first we'll install the TFTP packages here. So just to ensure that TFTP is enabled, TFTP and all the services are enabled. Now, okay, so now we will we need to run the TFTP service. So for that, we need to create one service file, a helper service file, which will call the start TFTP command, which will actually start the service. And let's create the helper script. And provide execute permission for the cells, the script, and start the service. Actually, like this procedure, I got it from that GitHub only. One thing that I don't understand is why are they calling it? See, they are calling this script. This script actually what it does is it does systemctl start TFTP. Why can't we do it manually? Anyway, we are doing it here. Crazy. I need to see why that is done later. Or now we will stick with this. So what are we doing? EOF and EOF ends here. Why it is coming twice? Okay, good. As long as TFTP is working, we don't care for these helper scripts. Now let's go ahead and then set up the boot files. So we'll copy all the sys Linux files from user share. This all will be the default boot files. And we'll also create a directory to put the kernel file and the init RAM file system. So when a PXE boot happens, these two will be supplied by the TFTP server. So for that, we will do that. Next, we should also download those files and put it here. All good. Now let's download the files and put it into that TFTP, that boot directory. So first we will download the CoreOS kernel file. Then we will download the init RAM fs disk file. Next, download the init RAM fs. We also need the live image that we will download it after we set up the Apache web server. Okay, all done. So just ensure the SLNX configurations are all properly done for the files. Now there should be two files in the tboot. One is init RAM disk, another one is the kernel. Well and good. So TFTP is ready. Finally, we will set up the Apache web server. So the Apache web server is the place where we are going to put the ignition files and all. And when the PXE boot happens, it will extract the ignition files from the Apache web server, and then it will start uh, the OpenShift installation. So for that purpose, we will be setting up the Apache web server here. So these are the steps. I had this pre-documented. So let me just take this and install it quickly. And this Apache web server, we are going to make it to listen on port number 8080. So just go to listen and make the port as 8080. Okay. Remove the welcome file, not required, and start the service. Ensure port number 8080 is enabled in the firewall. All good. So now create a directory to put the Red Hat CoreOS live image file. Download that image file and move that file to that web server. So this is where we need to also work on that X11 forwarding. Let's install this Apache web server, then we will set up that X11 forwarding. Okay, move that image file to the Apache web server and take care of AC Linux and configure the PX environment for the Red Hat Core OS using this Ansible. This will set up the PXE configuration files. Before we run it, let's have a look at this file, the task file. So here they are setting up the Bootstrap specific TFTP files. So here you can see they're getting this Bootstrap template and they are modifying the variables, then master, then worker. So let's take this and let's have a look at the templates. So this is the Bootstrap aspect where they configure the menu and everything. So by default, it'll do the Bootstrap node installation automatically. That is the default one. So when it is going to be invoked, let's create these files and I will show you the final output. That will be easier to understand. Let's not go into the Ansible aspects. So it's all created. Now, if you look into var HTML, here we have our RHCOS. No, not this. We need to look into the TFTP file. Okay. TFTP boot. Okay, let's go and look into this. So here you can see one file for each of the MAC address. We can have a look at this. There you can see this is for worker node. So in case of worker node, it is so here you can see we have given the init RAM disk and the console IP using DHCP. It will fetch the IP. Then what? The VDA, the disk, and here you can see we have given the image. So we can verify this. Let's just quickly set up the SSH forwarding, that extra forwarding. Uh, sudo vi etc ssh deconfig, go to x11 forwarding s, enable these two also. Now let me try to reconnect. Oh, still x11 forwarding is not enabled. Why is it so? We have just enabled it. X11 forwarding set to yes. Am I missing anything else? Root login is fine. And did I install? Oh, I haven't installed Xauth. Okay. Sudo apt install Xauth. See, that's why, like sometimes I miss it out. So that's why I just ensure that I put it when I do this basic installation. Okay, now disconnect, reconnect. You should see X7 forwarding enabled. Okay, this is something that you need to be there. Then go to tunneling at the toolbar. Let me delete this. I will start fresh. Create new SSH tunnel. Get the remote server IP address. Cancel this. Let's get the IP. What is this extra window here? Close this. Okay. Tunnel, new tunnel. Give that remote server IP. Port is 22. Wait. Remove this, remove this. The local port, I will give it as 9000. That is my local machine. SH server, give that IP address. Login. Wait. I will give it as SSH login, Rajan, port number 22. This should be enough, I think. Sorry, you have, okay. IP address 22. Is it all okay? Fine. Play this. Now I will use SOX proxy in the Firefox. Settings, go to the bottom, settings, just enable the manual proxy. So, SOX host, give it a local host, port number 9000. SOX v5 enabled, and the proxy DNS when using SOX v5 is also enabled. Now let's try to access that Bastion host from here. Okay, it's not able to connect. Why? Think 9000. Destination server 171. All good. No SSH key selected. But we already have SSH key configured. Okay, I will actually look into this later and I will let you know. For now, let's try this. I may be doing some simple mistakes. 8080. See, it actually works. So not an issue. I'll find out what is the problem with the tunneling and I will update you in the next session. Okay, so all configured. Next, we need to set up the load balancer and proceed with the installation. 10 minutes and we will kickstart the OpenShift installation. So configure HA proxy as load balancer. So install HA proxy. Oh, wait, I need to do it from Bastion host. Also, do necessary CDNS configuration for HA proxy to work well. And so here we are moving the default HA configuration. We will be creating our own by using Ansible scripts. So we can check the current configuration here. Okay, this is based on the template. Just come down. You will see the entries for OpenShift API server and mission configuration 22623 and ingress configuration port 80. That's it. So everything looks good. So let's go and enable the default ports of OpenShift 6443 used for API. And other things for mission configs, etc. Let's enable them. And also enable the firewall. I think it's already enabled. We don't have to enable it again. But these two ports we need to enable. Reload. All done. Say HA proxy is also enabled. Now we can go ahead and then set up the OpenShift installer. And then we will generate the ignition files. That's it. The work is done. So the installation might take an hour. Okay, so let's start. So first we will get install the OpenShift client. That is the OC, OpenShift client. Let's install it. It's downloading the tar file. And tar it. And move those two files, that is OC and kubectl. Kubectl is the client program for Kubernetes. OC is the client program for OpenShift. So both we will move it to user local bin and remove the other files. Now you should be able to see the version 4.18, latest one. Kubernetes 1.31, latest one. So both are ready. Now let's go and install the OpenShift installer. This is another CLI. This is used only for OpenShift installation. This is what will be generating the ignition files. Okay, then the one thing that I wanted to take care is this HA proxy part. I will remove this master 1, master 2 and all because I'm going to do the installation only for one master. So why to have this? Let me remove these two, right? Sometimes this might also create a problem. Worker node also I will have only one worker node. One worker node, one master bootstrap, one master bootstrap. That's it. We don't want any issues. This OpenShift is a horrible environment to debug. So move this OpenShift install also to user local bin and remove the other README and tar file, not required. Now OpenShift install also you should see 4.18.3. So their version should match. Now create the such keeper which we'll be using for our installation. So basically to log into the VMs, we'll be using this master worker node bastion host for that. Now let's go ahead and then create the pull secret. So the pull secret, you can get it from the Red Hat website. So you need to just have a Red Hat account. So here is the URL. Just go to that URL and log in and get it. Let me log into that URL. Okay, I think I logged in. Okay, so here you can see, once you log in, you'll be landing directly on the OpenShift web page here. You can see download pull secret or copy pull secret. Okay, you can choose either of those. I will use copy pull secret because it is easy for me to copy and paste. Otherwise, I need to download it to the Windows machine, then again upload it into the Linux machine. Too much work. So let me do it directly like this. So create this file. So here I will put that copied pull secret content. That's it. So once done, then next go ahead and then create a OCP4 directory where we will have all the ignition files generated. So go to the home directory. Now this is where we need to do the modification. So here, how many number of worker nodes you want and how many number of master nodes you want. So those things you can update. So here I'm just like giving it as one because I want only one master node and one worker node. And rest of the things I can leave it as it is, no problem. And here I'm getting the pull secret, I'm getting the SSH key, all are configured. These are the important places. So keep this file. So in case if the installation fails, we can retry it by using this file. So let's have a look at this content. See, basedomainexample.com, hyperthreading enabled, worker node 1, master node 1, metadata, IP. This is for the cluster networks, service network, the pull secret, SSH key, all are there. Okay, good. Now we can copy this into the OC4 directory. So that file will be removed. That's why I'm having one in the home directory. So whenever I want, I can recreate it. Okay, so now let's go and create the manifests file. So OpenShift install create manifest. So now if you check, it would have created a lot of YAML files. So, like this will take care of the machine configuration and everything. Maybe if you want, you can take a backup of this. So I will just take a backup of this. Maybe later I can use it for some reference. So next, let's go and update the master scheduler parameter. So if we just check here, VI manifests, cluster scheduler, 0 to config. So here we have master schedule. It is set it as false. So this will disable pods from getting scheduled on the master nodes. So here if it is false means, like master schedulable, no, we can't schedule the pods on master node. So we can change it to true. So that way, because ours is a small cluster, right? So we have only one worker node and one master node. So let's use master node also to place our workloads. So let's change this false to true. We want to enable the entries to be there. And this is only for test configuration. In real world, it has to be always disabled. So the Kubernetes manifest files are all created. Wait, let me take a copy of the backup now. Okay, all done. Now we can go ahead and then create the ignition files and place it in the web server and create the VM. That's it. Then everything else is automated. We need to just sit back and watch. So let me create so using the YAML files, it will be creating the ignition files. Here you can see Bootstrap, master, worker, and Kubernetes config and all are created. Now we will copy these files into Apache Web Server because this is where the TFTP command will fetch the ignition files for each of our VMs. So take care of the CDNX configuration too. And if we check the web server, you should see 3 files, master, worker, and Bootstrap. So now we can enable all the services, restart them, ensure they're all up and running. That means we are ready to go. So the only thing that is required now is we need to create the Bootstrap, master, and worker nodes, and we are done. Let's also create worker node 1. So what I will do is I will put all these commands into a shell script and I will run it. So that way it'll be much easier for me. Copy this. So here what are we doing? We are creating Bootstrap VM and RAM 16 GB. vCPUs, basically we are assigning 4 vCPUs. Okay, that's perfectly okay. And MAC address and all should match the MAC address in the DHCP. And next one, if you see, for master node, I will give 8 VCPs because it requires more power. And worker node, 4 and 16 GB. It's all perfectly okay. So what I will do is I will create, okay, I will just go to the hypervisor, temp a.sh. Put the commands one after the other. Let it create the VM. So this will do the VM creation and start the machine. Similarly, master node and start the machine. Worker node and start the machine. That's it. As of now, we have only one disk there. Let's go and run our script. So let's also look into the cockpit. We have only one machine. It's running, that is the Bastion host. Now run this. Bootstrap is getting created. If the TFTP is properly configured, it should start the booting process. We already have the live ISO. It should use that live ISO and it should start the installation. There you go. It started. Booting has started. Perfect. In the meantime, let's check ls -l var lib libd images. Okay. 50 GB. Good. Now you can see it is doing the CoreOS installation. And here you can check CoreOS installer install the disk ignition URL directly pointing to our Apache web server. That's it. So it has started the work. It just so once it's done, it will power off. We have the start command in our shell script, which will start the VM. And then it will start its installation process. Let me have 3 terminals here. Okay. I will log into that Bastion host. So, and from there I can log into the master node and the worker nodes and Bootstrap to ensure everything is good. Okay. Bootstrap. Okay. Where is Bootstrap? Here you can see Bootstrap is up and running. Click on Bootstrap. There you go. Now we can try to connect to it. Let me rename this to Bootstrap so you know what is what. SSH core at the rate of Bootstrap. .ocp4.example.com. Give the full domain. Yes. I logged in. You can run this command to check what and all is happening during the booting process. See, installation started. Similarly, you need to wait for the master machine. It is still not started. Let's wait. You can see the memory usage. Maybe I should have given even 32 GB RAM for like master. This is where most of the work is happening. So when it comes to the OpenShift deployment, whether it is bare metal or KVM, you need to set up load balancer, DHCP, DNS, TFTP to take care of the PXE booting in case if you're not doing it manually. So like these four services, then you need to create the ignition files where we do the necessary configuration for the OpenShift cluster. That's it. If you have these 5 steps, your cluster will be up and running. Now it is doing the worker node. So I should be able to log into the master now. SSH core at the rate of master. Yes. Master is also there. Now finally worker node. So you can see our first error is here. It is trying to access the Kubernetes API port, but still it doesn't come up. So it was waiting. Now you can see it is able to connect. API is up. First good news. Now it has started creating all the files and something or filing. Okay, these things are going to give us a lot of problems later. So we need to investigate and find out why it is failing. Anyway, the logs are all there. We will investigate later. So we will do a lot of troubleshooting to ensure everything is up. Okay, so the work is done here. Next, what we can do is we will set up the OpenShift CLI part. So in the Bastion host, we will set the kube config so that we can run the OC command or a kubectl command. Copy that kube config to the .kube config so that we don't have to do this every time. And ensure the ownership are all properly done, and also enable the autocomplete. So just tab will take care of the command completion. Source the Bosch RC. Now if you do OC tab, you should see all the commands. Beautiful. So OC, who am I? System admin. Okay. API server details, API OC for example.com. All good. Now let's try to get the cluster version details. Working towards 4.18.3. Okay, 65% completed. Good. Hopefully things goes well. When it comes to OpenShift installation, I am never confident. Okay, the master is also there, but it is not ready. We need to just wait for some time. And let's also try the cluster operators. Okay, so the cluster operators are slowly coming up. Not bad. So our goal is to ensure true for all these cluster operators. Then we are done with our work. That's it. Now, nothing to do. We need to just sit back and relax. I will just watch it. So Cloud Manager is up. Network is up. Cloud Credential is up. Come on, there has to be at least some services that has to go into error state. Uh, one service that might give you a problem. Ah, there you go. Lot of false. Okay. The ingress, where is that? Ah, I'm very curious about this service. Okay, so now nothing to do. We to just allow this, sit back and wait for it to come up. Most probably it may take an hour to come up. So once it is up, I will just power off this machine and keep it as it is. Next week we will restart it and we'll start playing with the cluster. And we also need to do the CRC environment, right? That also that we will do it in the next session. So with respect to HA, only one change. Instead of the number of master node, instead of one, change it to 3. Worker node, increase it to 3, 5, depending upon how many worker nodes you want to configure. In our environment, you can configure up to 3. That's it. So this multi-node deployment, whether it is a multi-master or single master, it's all the steps are the same as per what we have done today. Because ours is actually configured for 3 master node, but only thing is, with 3 masters, it really struggles. The infrastructure is not enough. So better to try with one master. You can try with 3 master, but you need to wait a long time for all the nodes to come up. Okay, so then we'll go with the CRC and OpenShift single node deployment. That's it. So if you just do this, deployment is over. Then we can go into DevOps. So the DevOps pipeline and all, I will not be doing it on-prem. Okay, instead, so only the deployment I will show. I will do it in on-prem. The DevOps use cases, either I will use IBM Cloud or I will use Google Cloud. I think Google Cloud is better. I have a lot of credit. So I can use Google Cloud and I can set up the DevOps, the like OpenShift using IPA. And then we can look into the CI/CD pipelines. Okay. Then my favorite, we will start. Okay, so we can stop here and continue next week then. Thank you.
Okay, thanks, Rajan.
Thank you, sir.
Thank you.
But take care.